I'm Avinash. I work for Celestica. I was not on the original menu today. I'll try and keep it short. I don't really, I'm not a true blue OpenBMC guy. I come more from a data networking background, but I got into building an orchestration software for managing a rack, and hence got a look at uh, accessing BMC like Redfish endpoints. So the prism with which I have looked at BMC is more from an end user application who tries and uh, accesses telemetry data and looks for efficiency in doing that. And one more thing we did as part of the system we built is we used OpenRM CDM, which is like OCP's rack manager software. It runs as part of our orchestration system. It kind of abstracts. It's similar to in the earlier AMI conversation, they were talking about a rack manager layer, which acts as an abstraction for the various BMC entities that exist in the rack and presents it as a single rack manager. So OpenRM CDM as an implementation is an open source implementation that facilitates that, and we kind of onboarded it into our orchestration software and did a bunch of extensions to it. The orchestration software we build, it's not really a commercially deployed one. It's more inward facing that our manufacturing test uses for our rack build outs for validating it before we ship stuff out to the customer. And as part of it, we do onboard various customer stray elements and the base BMC offering that they have. And what I'm going to talk about comes from some of the issues we face with that and what direction we could go in doing that better. There again, I mean, because of my background in networking, I kind of look at things with the prism of data networking. When I look at a Redfish schema, I'll start thinking, hey, what will be a Yang representation of this look like? I can't help avoiding that. So the current context of Redfish API, right? It is the spec will gets published as a bunch of URIs, which are essentially scalar, in the sense that if I have like 100 odd sensors and like 5 values per sensor, the set of Redfish APIs scale in proportion to the number of sensors and the number of values that get exposed, and that is what a developer builds on. At least the vendors the base offering, say we talk to a power vendor, the base BMC offering that we see from the power vendor is a set of scalar endpoints. I'm sure you can do batching, you can do a bunch of more efficient stuff, but the vanilla offering that we see is a set of scalar endpoints. And if I have to get multitudes of data, I will have to hit 100 different endpoints to be able to get all the data. Again, I mean, there are more efficient ways to do it, but that is the vanilla offering that we get. And one of the reasons I think it is this way is probably because the spec gives you a bunch of scalar representations. So like one thing that we hit recently is the customer needed at 30-second intervals every possible data, and one iteration of all the data that that particular power vendor had exceeded the 30 seconds. In essence, we cannot really hit the 30-second timeline requirement. So we ended up requesting them to build a OEM endpoint, which will consolidate everything that we need. And that you get it in like under 4 seconds. But this is not designed into the system, right? This is more like an afterthought where a customer talks to a vendor and says, hey, can you consolidate some of the things for me? So can we do something else in the context is the direction. That's the primary thing I wanted to talk about. GraphQL is like, it is widely used in the application world. It was actually invented by Facebook. GraphQL stands for Graph Query Language. Essentially, what it does is it allows the client to ask for what it wants. And so if I have a bunch of n different data points that I need, the client can essentially through a JSON format or something, say that, hey, these are the n things I want, and you get it in one shot. And typically GraphQL implementations, you will see a single API. It's not like Redfish is based out of REST, and you will have, like, depending on the scale of sensors and the data, you will have as many endpoints. GraphQL will have a single endpoint, and in that endpoint, the client specifies what it needs. So you pretty much get away from versioning, and you get away from the overhead of too many calls to get all the data I need. And hence you end up being a lot more efficient. Again, it comes with its cost. The server has more to do, like servicing a single Redfish endpoint. It's not very hard. There's not too much parsing to do. But if I have to service a GraphQL query, I will have to parse through a bunch of things, figure out what the client wants, get the data through dbus. Nothing changes there, but to figure out what the client wants, the server needs to do more. But all said and done, having a notion of consolidation is designed into the system, and it gives you flexibility into like by design, it's unrestricted. That's one. Another, there is no versioning. You don't have to go back and change code if you need some more data. You just, the client query needs to be changed to ask for what it needs. The backend code could remain the same. That's the general idea. But it is a big shift. So one other thing we could do is like have an intermediate step where you have a GraphQL proxy kind of thing running in a rack manager kind of setup. So the clients have the flexibility of asking for what exactly it needs. And the intermediate does the iteration. It's still not super efficient, but it could be an intermediate step to move in the direction of a complete GraphQL kind of service in the BMC server as well. Again, OpenRMC DM could be one place where we implement the proxy as an intermediate step. I just put in a sample query and response. Like I could say, hey, from these two sensors, I need the reading and I need the status. It's a consolidated request, and the response will again be a JSON that tells you on this specific sensor what is the reading, what is the status. So the general idea is more efficiency, reducing the number of calls that go from a Redfish client or an orchestration application to a BMC server, and hence reducing latency. Like, for instance, I mean, the frequent requests we get is, hey, I do not want all the data. These are the 5 things that I need, but I need it at 1 hertz. Like every second I need the data. So 5 things or 20 things, and I can't possibly make 20 calls and return the data in a second. We don't see that happening. So in scenarios like that, this consolidation from a client and the server serving it over one request, we are able to hit those in like early tests. But yeah, moving this into an adoption is a whole different story, but just wanted to talk about it and get feedback on what thoughts are. That's about it. Thank you.